Okay, this question, as it tells me, is about two graphs. And in the first part, I've got to show that the x-coordinate of any point of intersection satisfies this equation. Now, this is a show that question, and in a show that question, the thing they give you, this thing here, is my endpoint. So we don't get distracted by this. We're going to end up with this, but we don't know how yet. So the first thing to do is to ignore the endpoint and to find your starting point. And the key words in the question, the words that give away the starting point, are these. It's a point of intersection question. So how do I get points of intersection? Well, I've got two graphs with their own equations. Point of intersection means that I have to start by solving these two equations simultaneously. So my answer for part A, we'll start it here, involves taking the two equations, and we know that to solve these simultaneously I substitute one into the other. So let's substitute the first one into the second one. So we'll copy out the second equation, but I'm going to substitute in for y, so I'm going to have bracket for y equals x squared plus 2x. What am I going to change this y into? Well, the first equation tells me that y equals x plus k. So I've got x plus k equals x squared plus 2x. I'm going to get my 0 on this side. I'm going to have an x squared. What am I doing to both sides? I'm getting rid of x and I'm getting rid of k. I'm subtracting them both. So that's why x plus k turns into 0. I'm subtracting an x. I had 2x before, so now I've just got 1x. And I had no constant, but I'm taking away k, so I'm going to end up with minus k. So that's what simultaneous equation leads to. And look, I've arrived bang at the end point they wanted me to arrive at. So in a show that question, they give you where you're supposed to end up. This is the opposite way round, but I can leave my answer to that. Or, if you like, I can write x squared plus x minus k equals 0, because in a show that question, we really do want to very clearly arrive at the end point we were told to. Okay, so that was part A. Now in part B, given the graphs have just one point in common, find the value of k. So I'm going to be ending up by finding k. My starting point is this idea that it's just got one point in common. What does that remind me of? Well, the number of points in common will be the number of solutions to this equation. Remember, A and B, the parts will be linked. So I know that this equation is true at the points of intersection. Now I know there's just one point of intersection. This equation has just one solution. So that is the clue that I need to look at the equation I've just done. So my starting point is x squared plus x minus k equaling 0. But now this is a quadratic equation. The number of solutions is going to be worked out using the discriminant. So I'm going to need b squared minus 4ac. So I'm going to have a and b and c values. Okay, what's my a? Well, there's just one x squared. What's my b? There's just one x. What's my c? It's minus k. So I say that b squared minus 4ac is my discriminant. B squared minus 4ac equals, well, I'm going to work it out with a, b and c in just a second, but it's really important to actually decide what we know it's going to have to equal. So just one point in common. If there's just one point, then what do I know about my discriminant? Well, for just one solution, b squared minus 4ac equals 0. And it's absolutely vital that you set your stall out and you say what you want the discriminant to be. It'll either be greater than 0, equal to 0, less than 0, something in relation to 0. But we need to state that before we begin. Now I've got my a, b and c set up. I know what I want the discriminant to equal. I can put them in. So b squared is 1 squared. So let's go with the brackets anyway, even though this is a very easy example. So 4 times a times c, 4 times 1 times c is minus k. Be careful with these signs. I'm going to get, put in the other side, this is the b squared minus 4ac. I know it equals 0. So on the next line, 1 squared is 1. A minus times a plus times a minus is a plus. And then I've got 4 times 1 is just 4, so it's going to be 1 plus 4k equals 0. So solve this, subtract 1 from both sides. So I'm going to get 4k equals minus 1. So k equals minus a quarter. What was I asked to find? Back up there, find the value of k. That's what I've done, so I've finished. So there's my answer.